Welcome to today's webinar. Today we will show you how you can model and design insulating glass panes in RFEM 6. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the German and English webinars, technical content of the website, newsletters, and so on. I will be the moderator today and I will answer your questions during the webinar. My colleague Ulrich Lex will be the presenter today. He's the main responsible person for the glass design add-on, also for the masonry design add-on, and also for the construction stages add-on. Yeah, and he works also in the customer support team. You can ask questions when you press that button with the question mark, then enter your question in that field, press send, and I will receive your question and I will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. That should be all for the moment from my side. I hand over to Ulrich. Ulrich, you can start.
Thank you, Andreas, for your introduction. Also from my side, hello to today's webinar. The topic of today's webinar is how I model and design an insulating glass unit with RFEM. I want to show you the modeling and calculation of the system. I want to show you the generation of the loading, the external loading, and also the climatic loads. We can call it the internal loading. I can show you what RFEM is doing when we create an insulating glass and maybe how we can do some adjustments of it. And as a last point, I want to show you the documentation. That's all for the theory. I want to switch to the program now. As always, we start with a new file, with an empty file I created here. What I did is, can I show you in the base data? The base data, all things are default settings. What we need today is the add-on glass design. Here we have to check it on to get these items for glass in RFEM itself. As a second part, we have to choose the standard. For glass design, it's possible to use DIN 18008, the American standard ASTM, or a design check and stress check without any standard. Today I want to use the DIN 18008, and I have to set this also for the load case classification for the combination wizard, because here it's considered the load duration and these things. The rest of the settings are default settings, so I have not to explain it in detail, and we can continue with OK. So some basic settings, what we can change for glass. We can change the working plane, maybe in XZ direction when we have a vertical glassing, or we can let it as a horizontal working plane. It's up to you. We also can modify the space for the work plane from 1 meter to maybe 10 centimeter. So now when we start with glass things, we can use all RFEM things. as it is usual. So I can start with the thickness. Each surface has to have a thickness. That's why I can create a new thickness. If we check our glass add-on on, then we get a new thickness type. It's called glass composition. This glass composition, when I choose, then I get a new tab of layers. Here I can type in all my layers or my glass composition I want to have. That's what I want to do now. I create a new material. I want to choose a material from the database. Here I can choose glass. Maybe for today, float glass. Okay. With the thickness of 4 millimeters, I can create a new material for the foil. Again, to use the material library, want to use PVB. Okay, again, I can create here a new material for later, for a gas layer. Here I can choose maybe dry air or argon. It's up to you what you want to use here. Okay, as second layer, I want to have the PVB, and as a third layer, I want to use float glass. 0.52, that's the thickness, and 4 millimeters. So before I continue with the insulating glass unit, I want to show you two other examples as a laminated glass, only to show you the difference what the program does when we choose surface design or solid design. So I want to start with the easiest one as a surface, creation as a surface, and a laminated composition. So my composition is built up. Here I have also the total weight of this composition. So I have not to compute it manually. It's considered with the self weight. I can continue with OK. Now I can create my surface. When I create a new surface, I can choose my thickness with my glass composition and can create this surface. Maybe 1.3 meters and 70 centimeters width. So that's all I have to do. Now I have to continue with the supporting. As a support, I want to choose now a line support. It's acting in global Y direction. So I create a new line support for horizontal loads. It's acting in Y direction. Here it would also be possible to use the local coordinate system. For glass structures, it's maybe common to not to use a really fixed support. Therefore, you can use also a spring constant. Okay, and choose the lines. As a vertical support, I choose now here a node support. It's fixed in X and Z direction. On this side. And it's fixed only in Z direction on the other side. Okay, so now my glass surface is created completely. So when we now create a surface with a thickness of it's a type glass composition, then we get here downside at the glass design topics this glass composition model. Here a new glass composition model is created automatically because of this thickness type glass composition. The program tries to create for each for the same geometry of surfaces, for the same thicknesses, only one glass composition model. If you have different thicknesses, if you have different geometries, then for each surface is created a separate glass composition model. So I can, with double click, open this dialog. And I see this glass composition model is assigned to my surface number 1. And here with this glass composition model, I have additional settings what I can do, especially for our glass design. So the modeling type I want to choose for the first example is this surface model. This surface model is possible for laminated glass. That means that my glass composition is created as a surface. So it's computed with this stiffness matrix, what is displayed here in the third layer. At the second tab, I have it's only I see my thickness again. It's only info, what thickness, what layers are assigned. Here I get informations about the assigned line supports and nodal supports. I do not have to change here anything. So I can continue with OK on this place. So this is for a surface model and laminated glass. So now I want to define the loading. Here I want to create a new load case, maybe as a wind loading. Okay. And create a surface load. It's acting in Y direction, maybe 0.8, and I want to assign it to this surface. Okay. Now the loading is created and I could continue with calculation of the system and run also the glass design. One point I can take a look is the FE mesh. Here it's by default a setting of 0.5 meters. It's too rough for glass structures. I would recommend 0.1 meters or 0.05 meters. It's more exactly. So I can change it here. Okay. So as before I start with the calculation, I want to create the second option where I want to show you the solid type. So what can I do for the solid type? I create a new thickness to show you the things with a second glass composition model. I create again glass composition layers, float glass, and float glass the same settings as before. 4 millimeters. So if you have always the same composition, you also could save this composition as a template and load this template again and again for your user-defined compositions. So I can continue with OK. I can create this new surface now with thickness 2. OK. And create here the same structure as before. I want to use the same supports. This one apply, and here the second one, and the line support on this line. Okay. Also, the loading, I want to assign it on this surface too. So now, a second glass composition model was created because we have a different thickness used. So when I open this glass composition model, then I want now to change the modeling type from a surface model to a solid model. So for a solid model, again, I have these layers as an information. And additionally to only the information, I get now the option to set a reference plane. The reference plane says me in which direction my solid construction is created. So now the reference plane is set on the top of layer 1, and I can change it maybe to the bottom of layer 3, or I can change it to the middle. It's up to you. But we have to know that this reference plane says in which direction the composition is created, and as a second thing is that the loading is acting currently at this reference plane. So I show you how we can modify this afterwards, but as a first step we have to know this. So we again have here the line supports and the nodal supports. If we change here nothing, then the line supports and nodal supports are acting also on the reference plane. Maybe we can modify it here a little bit. The line supports maybe are okay, and for the nodal supports I can say, okay, these nodal supports are acting on layer 1 and 3, maybe in the middle. So what does this mean? We have here an item where we can switch between an image and the structure. That means that my supports are now acting in the middle of layer 1 and 3, or I can change it to the top, and so on. So when we now click continue with OK, then we can take a look what is happening in RFEM itself. So in RFEM, this glass composition model is red again because it could happen that the line orientations or the surface orientation is not exactly that what the program is needed. So we have one time to click OK or continue and click continue with OK and get this message that the program needs different line orientations. We can here easily continue with set required line rotations. Then my glass composition model is okay. If you create your glass surface in the horizontal plane XY, then it's okay from beginning. It's only when we use a different working plane, then we have to modify the line orientation. So what is now happen? Now the program creates additional solids in the background and also surfaces. These colored surfaces and solids are created from our glass composition model. We can display also this structure if we use this button. I call it always this magic button, display glass composition model. When we take this on, then we see that the program creates our composition as a solid. There was created two solids for the first glass pane, my PVB solid, and two solids for the second glass pane. They are created two solids because we set one support in the middle line. If you set the support on the inner or outer line, then only one solid is created. It's only a technical issue. So, but you have nothing to do with this automatic created surfaces and solids. So exactly, this is the difference between the surface modeling or the surface type and the solid type. Okay, now we are on the state. We can continue with the insulating glass. For the insulating glass, I want to do the same. I can create only a thickness, a new thickness for my insulating glass pane. So I want to use glass composition, choose my layers, say okay. As a first, I want to have float glass, maybe PVB. I have to set the thickness, the float glass. So, and now I only have to set here my gas layer, 16 millimeters, and as a second side I can use again my float glass. So it's not limited. We can also create here a triple insulating glass and so on. If you assign here a gas layer, then you see the composition is displayed here correctly with the gas layer, and also the total weight is considered automatically. So this is everything we have to define also for the insulating glass, and can here continue with OK. Again, I create a new surface to show the difference. Use now my insulating glass thickness and create the same surface. It's also possible to maybe set the supporting node on the edge. Therefore, I created here new nodes. I have to connect these nodes with the lines and can set here again my nodal supports. On the one side and the other side. Okay. And the same for the line support. And click with OK. As a loading for wind loading, I want to use also the same as for the other. And additionally, I want to create a new load case. Maybe an imposed, where I want to set a line load. Maybe use this new free line load. It should acting in XZ plane in direction Y. For example, here, and assign it to this surface. Okay, I want to change the direction. Okay, this I want to use as an additional load case. So now we see again a new glass composition model is created. When I double click, then I can open it. So here is now the modeling type, only the modeling type solid model possible. I get here as an options, a few more options for insulating glass unit and additional for climatic loads, summer and winter. So when we take a look at the separate tabs, I have again these layers with my reference plane. I do not want to change it. I can set my line supports. My line supports I want to modify now. Maybe I want to set this line support on layer 1 and layer 5. So I can choose it here, layer 1 and 5 in the middle. And the middle. 1 and 5 in the middle. I have to set it. In the middle. So I press once apply. I get my message to change this line orientation. Can continue with OK. And can continue here with nodal supports. For the nodal supports, I want to set this on each glass layer. In this way, it's because that I get not problems with self-weight maybe. Here I could also use some non-linearities, maybe when I want to have that it's a failure if tension is in the support. But for this example, it's okay when we define it in this way. So as an insulating glass here, we would have the option to change the settings for the space. I would say we can modify the thickness of this side surface of the solid, and also we could deactivate this helper supports what we use for this gas solid. But in our case, I do not want to change something here. So I can continue with OK. And at the first step, we see nothing. Again, there are a lot of new solids are created automatically, and there are a lot of surfaces created automatically, but we have nothing to do with this. We can again take a look at this glass composition model. I can modify the size of the hinges, and also for this supports. So what we now see is that the program or this glass composition model creates our composition with solids in RFEM. Okay, one step I forgot, so I have to go back to the glass composition model. This is the climatic loads for summer and winter. If we have an insulating glass unit, it's usual to consider these climatic loads. So we can check on both items. We get this new tab for climatic loads. Here for these climatic loads, I can use the input as specific values according to the standard, or I only can use these differences to set the values directly. Here I had to create a new load case for the high difference. If I do it here from this tab, then I get automatically the setting. It's a situation summer, so it will not be combined afterwards with the situation winter. I can continue with OK. And the same for temperature differences and atmospheric pressure differences. Here I want to use load case 5. My settings are according to standard, so I let it as they are. The same for winter. I create a new load case for winter. Again, this high difference, load case 6, and the additional setting for winter. Okay, and the same for temperature and atmospheric pressure. So that's everything we have to set here in these both tabs. When we click with continue with OK, then we see that the load cases are created, and the loads are created too, what are acting on the gas, or on the glass, on the insulating glass unit. So it's on the one time 2 surface loads, and on the other time 1 temperature load and a surface load. The same for the winter situation, for the high difference and the other one. So now we are completed with our modeling. One take on the loading for the wind load. As I said, the wind load is now acting on my reference plane. So my reference plane is now, as we set it, on the layer 1. So my construction is created in Y direction. So my wind load is now acting here in the front of layer 1. This is okay for this example, but my second load is acting or should acting on the opposite, on the other side. So currently it's acting on the reference plane too. We see this, or we can check this if we click into the load. It's assigned to surface number 29. When we take a look on the surfaces, then we see that our reference plane is surface number 29, but this load should acting on the other side, and this would be surface number 44. So we can easily change this when we open this surface and assign this load to surface number 44. So now the load is acting on the layer number 5. So additionally, we have now all items directly in RFEM. So it's thinkable if now this glass pane is a little bit different, so that here is maybe it's the width is a little bit bigger as the glass pane in front. It would also be possible to create here an additional glass solid. And we could also design this additional modeling. It's not possible in all cases, because we have to be sure that our created solids and our created objects are not destroyed. But in a lower but in some cases you could try to do here an additional modeling to design some special cases. This would be also possible. Okay, now the modeling is completed. Then we have to we want to create the FEMesh. I want to generate it. Yes, I want to generate it. We see the a regular FEMesh. I think it's okay. For this solids, By default, there is a mesh refinement. The layered mesh is activated, so that the FE mesh in this solids is quite regular. So for the next step would be the calculation, the static analyze setting. We can take a look at there. If you use insulating glass or this gas solid, then it's set automatically as a large deformation analyze. And I would recommend this always, also for laminated glass, because only the membrane stiffness is only activated for this large deformation. Of course, you could use for some easy cases also calculation of theory first order, but I would recommend always this large deformation analyze. Okay, now we can continue with specials of glass design. The glass design settings itself are in the surface. When we edit a surface, we have here the design properties. They are checked on automatically when a thickness with glass is assigned. Here you can do some design configurations, or you can change this design configurations according to the standard. You can choose any different settings for surface solids, where you can change also the standard parameters. In the second tab, you can do settings for the deflection analysis. Here the reference length is 0.7. This is okay. Only at in the last surface we have to change it. Here's because of minimum border it's 0.1. Here we have to change it when I choose this length. Okay, this changes I always do on my created surface, and when I now take a look at my computed solids, maybe float glass solid, we see that the deflection for this solid is changed automatically, and I do not have the chance to modify here something, because it's always connected to my created surface. Okay, the glass settings itself can we show here. We have our design situations. When I take a look at the design situations, I have here created automatically two design situations for the ULS and the SLS. Then the load combinations are created. Here we see that the load case 4 and 6 are not combined together. This was because of the setting for summer and winter, so I do not have to take a look at it. It's also possible to set here, to set this everything manually, but then I have to create here additional settings with inclusive or exclusive load cases that say load case winter and summer are not combined together. Okay, the load case itself, as I said at the beginning, when we use the combination according to DIN, we have here also settings for the load duration. For self-weight, maybe it's permanent. For wind load, it's short term, and so on. This is possible to change manually too. And these settings are again for the load combinations. Okay. In the class design, we have here our design situations, what should be computed. Here I have the possibility to compute all load cases, all load combinations, or choose only selected one. Today I do not want to compute. I do not want to compute all combinations because of the time, so I select only a few one, and the same for SLS. I only want to choose a few one combinations to compute. So objects to design. I get here. I can choose here what objects should be designed. It's one time this surface, this selected surface. On the other side, my automatically generated solids as surface solid model, because we create only a surface and the solid is created automatically. And it would be also possible to create user-defined solids and to design them here too. So I have some objects to exclude, so I choose, as I did it here, only some load combinations, and here I get all the other informations. So here I get an overview. For the overview, I get some errors, I would say. Maybe solid 23 is not designable. When we take a look on the solid 23, then we see why it is not designable, because it's my guess solid. And the same is for the other. For solid 3823, configuration is deactivated. What is the reason? Because my solid number 3 is my PVB foil, and also 8 and 23. So these errors could be ignored. It's only an overview and an information. So now we can start with the calculation. For the calculation, we can use now this calculate all or calculate class design. I want to choose now calculate class design. When we click this button, then the calculation process is starting. We see here the separate combinations what are computed. We see here the method large deformation, and we see here the convergence diagram on the right side. So at first the calculation for the load combination is running, and after this the class design, the stress comparison is running. Okay, when the calculation is finished, then we get I would say two results. On the one side we get the results for the glass design, and on the other side we get the results for the static analyze. When we take a look on the results for static analyze, then here we get all the things of like deformations, the stresses for the surfaces, and the stresses for the solids. Also the results for the gas, the pressure inside the gas, and so on. I can take a look on the support reactions and everything what is included to the static analyze results. For the glass design results, we get the ratios. The ratios on surfaces and solids graphically, and we can also activate the values on surfaces, also for grid points or also for the mesh points. In the result table, we get here the design ratio. The design ratio for the different situations. On the one side, the design ratios on surfaces and the design ratios on the solid model. So if you double click on this design ratio check, we get also detailed informations about this check. We get the information which formula of the standard is used with. We got exactly the values for this design check. Okay, the same for surfaces. We can take a look on a diagram at the surface point. Here we can take a look at the stresses through the thickness and can check here all the things. These things also can be printed to the printout report. The printout report itself, can be created in the data navigator. When we create here a new printout report, when I open my created one, then we see that there are a lot of results in form of a table. These things we can modify user defined when we optimize this printout. When we open this printout report manager, here we can check off all the items what we want to see in the printout report. As a table, as table results. And the most important thing for me, I would say, is to get some graphical results. Here it is possible to print this. To select one surface and print this picture directly to the printout report. if we do this, we got a lot of settings to create the page. We can save and show. The printout report is open again, and this picture is printed to the printout report. So this can be moved also, and on a different place. So it's up to you. Okay, now I'm at the end of my presentation. I want to say thank you for listening. Hopefully it was interesting, and I want to give back to Andreas.
Thank you, Ulrich, for your presentation. At the end, I have an additional hint for you. You can book our online courses. For example, the RFEM 6 course, that's a course for beginners. Then the Eurocode 2 course for the concrete design with RFEM 6. The Eurocode 3 course for the steel design. The Eurocode 5 course for the timber design. And the Eurocode 8 course for the earthquake design. For more information, just scan the QR codes or click at the links here. You can get such a course for free when you submit your customer project, and we have published it. Yeah, the courses are valued at 199 to 399 euros. Yeah, just click at link, and you can also scan the QR code. Then a hint to our free online services. For example, the Dlubal community. You can ask questions there to our software, to structure analysis and so on. And our users or our employees will answer you. Then you can determine snow, wind, and earthquake loads in the geozone tool. You can determine cross-section properties. And you can also download 3D models, for example, as a template for your project. For more information, just visit our website, dlubal.com, where you can find the recorded webinars, for example, and other videos. You can ask our AI assistant, Mia, all the time, 24/7. Just try it. Okay, that's also all from my side. I thank you for your attention. Thanks again to Ulrich for the presentation. I hope we meet each other in a future webinar. See you. Bye-bye.